Hi, hello everyone. So today we're going to have a look and explore some more about lines and circles and how they interact with each other. So we're going to look at a couple of scenarios today, probably really cool scenarios, but scenarios that usually evolve around this kind of idea, where a line and a circle interact and you're really looking for the points of interaction and how we go about figuring them out. Now, obviously, it's created a chord. That line that's gone through that circle has created a chord, and then it'll always be a chord until you get to this point here, in which case you have a tangent. And we've already looked at a couple of strategies about how to get the equation of a tangent at the point of contact. So there's a couple of strategies there we've looked at in the previous videos, but now we're looking at strategies really about where the two interact. So I suppose, listen, we'll go right into it. So let's say you have a line x plus 2y minus 1 equal to 0. And let's say you have a nice little circle, x squared plus y squared plus 2x plus 8y minus 8 equal to 0. And you want to find where the two of them intersect. Okay? So what are we strategies, first of all? Okay, I suppose that's probably the key thing here is what strategies are we going to use to kind of work this out? But you can see for yourself that you've got a linear, obviously, and you've got a circular. So we've done this before when we were doing simultaneous equations. We're going to do this by substitution. Now the trick when we're doing this is when you're rearranging this in order to substitute it in, try to avoid, if possible, creating a fraction. And what I mean by that is, I'll show you to just down here, and then I'm going to rewrite the question and do it in full. But you could rearrange this two ways. So I'm just going to rewrite this here. You could rearrange it where x is equal to minus 2y plus 1. Okay, so that's one possible way of rearranging it. Or you could, if you were a little bit kind of not happy with it, you could rearrange it as y is equal to 1 minus x over 2. Now, this is the option you go for. You try to avoid a fraction substitution. Sometimes it will be impossible to avoid it, in which case I would always try and go with the fraction substitution that's easiest to do. Okay, but try and go for the non-fraction one. It'll just make it easier to do. So I'm going to rewrite these on a fresh page, and we're going to substitute it in and see what happens. Okay, so we've got x plus 2y minus 1 equals 0, and we have x squared plus y squared plus 2x plus 8y minus 8 equal to 0. So we're going to substitute one into the other. So the first thing we're going to do, x is going to be equal to 1 minus 2y. Okay, so I'm going to substitute that in wherever I see x in this one. So I'm going to have 1 minus 2y squared plus y squared plus 2 times 1 minus 2y plus 8y minus 8 equals 0. So that's our first line of work done. Now we just have to multiply out the brackets, tidy it up, and you can see straight away it's going to generate a quadratic, which you'll solve for y, substitute back in, solve for x, the usual type of scenario. But I suppose this is the line. After this line is where things can get a little bit tricksy and where things might go wrong. So what's our rules here? Square the left, square the right. Multiply them together, minus 2y, and double it. Okay, plus y squared plus 2 times 1 is 2, minus 4y plus 8y minus 8 equals 0. Okay, so we're going to have to do a bit of tidying up here, but it's not the worst tidying up I've ever seen in my life. Okay, so let's do the y squares first. I have a 4 and a 1, so we've got a 5y squared. Okay, let's do the single y's. I have a minus 4y and a minus 4y and a plus 8y. Well, that's 0. That solves that problem. And then let's do our constants. We have 1 and 2 is 3, minus 8 is minus 5. Oops, sorry. So minus 5. So this one has actually turned out very nice. Okay, so we have two possibilities here. Okay, that's the same as divide across by 5, y squared minus 1 equal to 0. Okay, so y is going to be plus or minus 1, isn't it, really? But let's do it anyway. Y squared minus 1, that's y plus 1 by y minus 1. That's because it's the difference of two squares. Y is equal to minus 1, y is equal to 1. So there's my two y values. Now I can substitute them both back in. So at y equal to minus 1, then x, in this case, if y is equal to minus 1, then x is going to be equal to 3. And at y equal to 1, x is going to be equal to minus 1. So we have minus 1 and 1. And this is important that you write down the coordinates. And we have whatever, 3 and minus 1. You have to write down the actual coordinates, because if they're asking for the points of intersection, they're not looking for this. This gets you like 8 or 9 out of 10. This gets you the full shebang. So you really need to write that down. Okay. I can't emphasize that one enough. Okay. We'll try another one. Okay. God loves a trier. We'll try another one. So let's try 2x minus y plus 8 equal to 0. And let's do x squared plus y squared plus 4x plus 2y equal to 0. Okay, so I'm going to do a 3-to-1 pause on this one. I want you to give it your best shot of Rooney. Okay, so 3, there's a little kick in the tail of this one. 3, 2, 1, go. And we're back. Right, so let's have a look at it. Decisions. Which one do I make the subject of this? I go for the y, because if I go for the x, I'm going to have to get a fraction going, and I don't want to go that route. So that's going to be 2x plus 8 equal to y. So y is equal to 2x plus 8. So we're going to substitute that one in. So we're going to get x squared plus 2x plus 8 to be squared plus 4x plus 2 times 2x plus 8 equals 0. Okay, so that's going to be x squared plus, well, what's going to be this? We're going to square the left, that's 4x squared. Square the right, 64. Multiply them together, 16x, and double it, 32x. Plus 4x plus 4x plus 16 equals 0. Right, let's do our tidy up. Okay, tidy up. Add that and that, I get 5x squared. Okay, 32x, 4x, and another 4x is 40x. And then 64 and 16 is 80. Now, it looks daunting, but everything there divides by 5. 16, I think. 4. Okay. Remember I said there was a sting in the tail? So x plus 4, then x is equal to minus 4. But there's only one of them, because the other one is also x is equal to minus 4. So what's that telling us? Well, if x is equal to minus 4, that's minus 8 plus 8. Y is equal to? So minus 4 and 0 is the only point. What does that mean? It means it's a tangent. So if you can only get one possible version out of it, you're dealing with a tangent. Because if there's 2 possible x's, that gives you 2 possible y's. That means a chord. It's making a chord. So there's your proof that it's a tangent. If you're ever asked to prove it's a tangent using this method, there you have it. Okay, quite an interesting one. Let's try another one. So I'm going to get a ruler here if I can. So okie dokie. So there's the x-axis, there's the y-axis. And there's a circle. Okay, and as you can see, the circle touches the y-axis and intersects the x-axis. So the question to you is, if all we know about this is the equation, can you figure out those 2 points? Okay. So I want A and B. So we need to find A and B. Okay. So let's think of a strategy how we will go about doing this. Okay. What do we know? We know that on the x-axis, y is equal to 0. Yeah. So we know this line here is y equals to 0. So that means you could make all of those things 0, which leaves you with just an x, which you could then solve and then figure it out. Well, let's give that a go. So along the x-axis, y is equal to 0. So we're going to have x squared plus 0 squared minus 10 times x plus 8 times 0 plus 16 equal to 0. So we're going to have x squared minus 10x plus 16 equal to 0. That looks like it's solvable. We're looking at 8 and a 2. 2 minuses. X is equal to 8. And x is equal, sorry, I've done that the wrong way, but you know what I mean. X is equal to 2. And that makes sense because look, they're in the positive, they're positive x values. So we just need to figure out which one is which. Well, if you substitute both of them back up in there, the y is going to be 0. So we have 8 and 0 and 2 and 0. So that has to be the 8 and 0 because it's further to the right. And that has to be the 2 and 0. There you go. Oh, that was a nice kind of nice one, I would say. Very nice one. Yeah, that's to me that would be a bit of fun, I suppose. Okay, so we're gonna do one more, and this next one is like the epic cool one ever there was one. Okay, now. So here we go. Find the equation of the green line. Okay, so this is a chord that's common to circles 1 and circles 2. So if I cover circle 2, you still have a chord going through circle 1. Same thing, cover circle 1, I have a chord going through circle 2. So it's a common chord going between the two of them. And the question is, how could you find the equation of that common chord? Okay, if they're intersecting, it's a chord. It's obviously. If they're just kissing, it's a tangent. So if I did a smaller version of it down here, I'm going to try my best here, lads, so bear with me. You know, if they're just kissing, it's a tangent, okay? You know, if they're just kissing, it's a tangent, but we're talking about a chord first of all. So how would we have a look at it? There's a couple of ways you could go at this. There's a lot of ways you could go at this, really, actually. You know, I would, if for example, you knew the distance between the centers, then the chord would be midway. You get the midpoint of that line. You know, that type of way. There's one way of doing it. And of course, it would be perpendicular because we know the line drawn from a chord, you know, that type of way. So that's one way of doing it. So let's find the equation. And then from that equation, let's maybe find those points. So let's do some fun on this one. Okay, so I'm just going to move it over here so everyone can see. So we need a bit of information to make this work. Now, usually they'll tell you the circles. Okay, so I'm going to tell you the circles. So one of the circles is x squared plus y squared minus 6x plus 2y plus 4. And the other circle is x squared plus y squared plus 2x minus 4y minus 6 equal to 0. So let's call that circle 1 and circle 2. Okay, so you have information there, and from that information, you could get a lot of things out of it. For example, you could find the centers. Okay, you could go draw a line between those centers. You get the equation, or so you get the slope of that line, get the perpendicular slope, get the midpoint. You could do a lot of work there. Okay, but that would take a while to get that chord. There's a quicker way. Okay, now how this was figured out. Okay, how this was figured out is that some genius, okay, some genius just figured out a quick way of kind of doing it, for want of a better word, and it just worked for them. So what they did was they said, well, if you take circle 1 from circle 2, you'll actually end up with a linear equation. And that linear equation will actually be the chord. So we're going to try that. So we're going to take these two things away from each other. Now, you can take them away two different ways. You can put them side by side and take them away, or you can take them away by just lining them up and changing the signs on one of them. Okay, so that's what I'm going to do. So I'm going to go x squared plus y squared minus 6x plus 2y plus 4. So I'm going to take away 2 minus. So everything here is going to have to be changed. Minus x squared minus y squared minus 2x plus 4y plus 6. Now watch. Gone, gone. Minus 8x plus 6y plus 10 equal 0. Okay, that will simplify. Minus 4x plus 3y plus 5 equal 0. And there you have what you need. That's him. Now, how would I find these points is probably a harder question. Well, now we just go back to our usual. Okay, pick one of your circles, pick your equation. Now, you can see what's going to happen here. Now, I'm going to do it for you because, well, why not? But let's have a go of it. Now, so I'm going to have to move on to a new sheet, unfortunately. But as you can see, this is going to be a bit of fun. But we'll try it, you know. We're going to have to try it. So, let's give it a go. It's not going to be pretty, but it will be done. I'm going to pick one of the points. Let's go with x squared plus y squared minus 6x plus 2y plus 4 equal 0. Okay, and I'm going to go with minus 4x plus 3y plus 5 equals 0. So there's my 2 points. Okay, so what we're going to have to do is rearrange. Okay, we will maybe rearrange the y. We leave the y. So 3y is equal to 4x minus 5. Y is equal to 4x minus 5 over 3. So everywhere I see y, I had to replace it by that. So I'm going to have an x squared plus 4x minus 5 over 3 squared minus 6x plus 2 times 4x minus 5 over 3 plus 4 equals 0. Okay, x squared. Now, I'm just going to park that for a second and do the rest. Okay, we've got minus 6x plus 8x minus 10 over 3 plus 4 equal to 0. Okay, I know everything's going to be multiplied by 9 anyway. It's going to have to be. Okay, so how do we do this bit? Well, we do it in stages. Let's square the top bit, square the bottom bit. The bottom bit's easy enough. It's going to be a 9. Okay, the top bit is just our usual method. Square the left, square the right, multiply them together. That's minus 20x. That's minus 40x. Now, it looks horrible, doesn't it? But you can see that everything there can be multiplied by 9 and it will get rid of the fractions. So we will do that. So I'm going to multiply everything by 9. That'll be 9x squared plus 16x squared plus 25 minus 40x minus 54x. Now, multiplying that by 9 means multiplying everything there by 3. Plus 24 minus 30, 24x minus 30 plus 36 equals 0. Oh, mother of God, this is going to be epic. Okay, so let's add the x squared. There's only 2 of them. It's not too bad. So 25x squared. That's that bit problem. The minus 40 minus 54 is minus 94 plus 24. Minus 94 plus 24. Now listen, at this stage, I'm going to get Mr. Calculator out because I'm not going to risk at this hour of the morning getting this wrong. Minus 94 plus 24 is minus 70. And then what am I left with? 25 minus 30 plus 36. Oh, you must be joking. Okay, 25 and minus 30 plus 36. Oh my God. Okay. 31. That's a prime. So it doesn't have any factors. So you can see where this is getting fun. So I'm just going to start cheating now because, you know, I can. 25 minus 70, 31. So x is equal to 2.25 and x is equal to 0.55. Okay, which means you substitute them back in to get your y equal and y equal to. Okay, so if I substitute 2.25 back in here, 4 by 2.25 minus 5 divided by 3, node 1, menu 1. Okay, 4 by 2.25 minus 5 divided by 3. So that's 1 and 1 1/3. That's 4 over 3. And if I put in 0.54 by 0.55 minus 5 divided by 3 minus, oh Jesus Christ, minus 0.93. Okay, I never said these were pretty. Never said that. Okay, but I just said that's how you would do it. If now I'm assuming in an exam they would not have them that crazy. Even if they were using a fraction, they're not going to come out that crazy. I just did it to show you that you can go down this rabbit hole and it will work. Okay, thank you very much. Goodbye.